Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to an aviation school. This is Emdadul, assistant teacher of mathematics, National English Version School, Daship. Dear students, today I am going to conduct a higher mathematics class of class 9. Our today's topic is exercise 2, question 7, 2 and 4 I will solve in our today's class, and from question 7 6 is given for your homework. This is your homework 26. Okay dear students, so you will do your homework properly and you will submit timely. Okay dear students, let us see. In our today's class I will solve two factorizations. It means that I will solve two questions. The questions are resolved into factors. It means we have to express these fractions, express these polynomials as product of some fractions. We have to product of some factors, and we have to express these polynomials also as product of some fractions. Dear students, I have written two problems here. These two problems we have to solve using two methods. First one I have to solve using remainder theorem, and second one I have to solve using the method of cyclic expression. Okay dear students, so let us see. First one, how can we solve? Solution. As we need to factorize this expression, and I have told that first one I have to solve using remainder theorem. So at first we have to consider this is a polynomial of variable a, so we can take let, we can write here let P of a is equal to 4a to the power 4 plus 12a cube plus 7a square minus 3a minus 2. Dear students, you know that in case of remainder theorem, when any expression will be divided by another expression, then the remainder must be 0. It means that when we will get any factor, then the remainder must be 0. So we have to consider a definite value of a, so that P of a equal to 0. It means P of that value will be 0. So we can check for which value of a P of a will be equal to 0. We have to check. Now we can check by, if we consider here 1 value of a, if we consider a equal to 1, this will be 4 into 1 to the power 4 plus 12 into 1 cube plus 7 into 1 square minus 3 into 1 minus 2. So if we calculate 4, 12, 7 minus 3 minus 2. So this will be 16, 23 minus 5. So this will be 18. So this is not 0. We need to consider another value. If we consider minus 1, now we can consider minus 1. If we consider minus 1 as value of x, what will be done? If we consider minus 1, then we will get here 4 into minus 1 whole to the power 4 plus 12 into minus 1 whole cube plus 7 into minus 1 whole square minus 3 into minus 1 minus 2. Now if we calculate, this will be positive, so 1 to the power 4 will be 1, 4, so we will get here minus 12, we will get here minus 12 plus 7 plus 3 minus 2. So if we calculate, we will get here 4 positive, 7 positive, 3 positive. So if we add this 3, we will get 14. Now minus 12 positive, minus 2 here, minus 12 here. Minus 12 and minus 2 will be minus 14. So this will be 0. It means that if we consider a equal to minus 1, then P of minus 1 will be equal to 0. So we have to take the value of a, that is minus 1. So we can consider here minus 1. We can write here now. So P of minus 1, P of minus 1 is equal to 4 into minus 1 whole to the power 4 plus 12 into minus 1 whole cube plus 7 into minus 1 whole square minus 3 into minus 1 minus 2. Now put the value, calculate here. 4 into 1 plus 12 into minus 1 plus 7 into 1 minus plus and product of minus and minus is plus, this will be 3 minus 2. So we can calculate here 4 minus 12 plus 7 plus 3 minus 2. So this will be minus 12 here, not plus here. So this is 14, 4, 7 and 13. If we add, we will get 14, and minus 12 minus 2 is minus 14. So this will be 0. As this is 0, we have taken a equal to minus 1. So if we take in one side a plus 1, this will be equal to 0. It means a plus 1 will be a factor of p of a. So we can say, as the definite number is minus 1, so we can say a plus 1 is the factor. So, or we can write therefore a plus 1 is a factor of p of a. Now, as a plus 1 is a factor of p of a, now we can determine the other factors here. To determine the other factors, we have to write the expression here. 4a to the power 4 plus 12a cube plus 7a square minus 3a minus 2. Okay, dear students. So, what can we consider here? Dear students, in this case, if you can apply a technique, at first give 2 equal, and in the second equal, you have to use a plus 1 as factor, and then take here 4a cube as common. If you take 4a cube as common, you will get here 4a to the power 4 plus 4a cube. Then calculate. If we multiply by 4a cube, we will get this. Now 4a cube I have written, but we have 12a cube, so we can write here 8a cube remaining. So we can take a plus 1 factor again, and we can take here 8a square as common. If we take 8a square as common, so we have to multiply by this. If we multiply 8a square by a, we will get 8a cube. Now multiply the second term, we will get here 8a square. But we have 7a square, so we have to subtract a square. To get this a square, we need to take minus a as common, and a plus 1 is the factor we have. So we can write here product of a and a is a square. Here is minus, so minus here, plus and minus is minus a. Now we need 3a, but we have got only 1a, so we need minus 2a. So take minus 2, take minus 2 as common, you will get here a plus 2, product of these two, minus 2 here. So 2 and a is minus 2, and minus 2 is, and 1 is minus 2. So we will get here a plus 1 as common, and remaining 4a cube plus 8a square minus a minus 2. Okay, dear students. So now here is also another expression. We have to factorize this expression again, and for this expression we have to apply the technique remainder theorem. We have to apply the remainder theorem here again. So to apply the remainder theorem, we need to consider this is the polynomial. So we can write here again let we can say this is equal to equation 1. We can say here again let q of x is q of a variable a is here equal to 4a cube plus 8a square minus a minus 2. So we have to write here 4a cube plus 8a square minus a minus 2. So we can consider here another one. What we need to consider here? If we consider here 1, 2, If we consider, this will never be 0. If we consider 1, if we consider 2, it will be 0. But if we consider okay, so we can write here, so q of 2, calculate here, q of 2, q of minus 2, consider q of minus 2. This will be 4 into minus 2 whole cube plus 8 into minus 2 whole square, a into minus into minus 2 here. So we can write here, if we consider here minus 2, then we can write here 4 into minus 8 plus 8 into 4 plus 2 minus 2. So we'll get here minus 32 plus 32 plus 2 minus 2. So we'll get here 34 minus 34, it means 0. So we can say a plus 2 is also is also a factor of q of x. So we can write here, so, or we can write therefore a plus 2 is a factor of q of x. Now, or we can write now the given expression 4a cube plus 8a square minus a minus 2. So give double equal here and write the factor a plus 2 here. So to get 4a cube, we need 4a square here. We need 4a square here. Now if we multiply by 4a square, we will get here 4a cube plus 4 to 0 8a square. This matched, so we can write here a plus 2 again. If we take minus 1 as common, we will get here minus s minus a minus 2. So we can write here a plus 2 as common, and we can write here 4a square minus 1. Now here we can apply the formula. Here we can apply the formula. If we apply the formula here, we can write here a plus 2 into 2a whole square minus 1 square. It means a square minus b square here. So if we apply, we will get here a plus 2 into 2a plus 1 into 2a minus 1. So we have factorized the expression, this one, it means q of x, q of a. Now we need to use this in equation 1. So if we use this in equation 1, we will get here, therefore from 1 we get 4a to the power 4 plus 12a cube plus 7a square minus, here is 3a minus 2 is equal to, we can write this one, a plus 1 into 4a cube plus 8a square minus a minus 2. Now we can put the value of this as we have factorized this. So we can write here this means if we factorize this, we will get a plus 2 into 2a plus 1 into 2a minus 1. So I have done here the factorization is done here. Okay, dear students. So question 2 is done. Question 2 is done. Dear students, I hope you have understood how to factorize this question or how to resolve into factors. Okay, dear students. So I have done first one. Now I will do second one. Second one, I have to solve, apply another method. The method is cyclic expression. Method of cyclic expression. Dear students, so you need to know the cyclic expression. I have discussed about cyclic expression in the first class of this chapter. In basic discussion I have discussed. So we can say cyclic expression, using cyclic expression, if we recall that, we can write here A, B, C. So if we consider in this way, these three variable A, B, C, or three numbers or 3 symbols if we use, then after we can say after A we will get B, after B we will get C, after C we will get A. It means the order we have to maintain in case of cyclic expression. So if anyone want to write AB plus BC plus AC, this will be wrong. After A will not get C, after A will get B, so after C will get A, so this should be CA, not AC. So in case of cyclic order we have to maintain the order, So we have to write here CA, not AC. We can't write BA, we have to write AB. We can't write CB, we have to write BC. So in case of cyclic expression we have to maintain the order or the sequence. So we can solve the question depending on this. We can write here for solution. We can write the given expression here, x into y square plus z square, x into y square plus z square plus y into plus y into z square plus x square plus z into x square plus y square plus 3xyz. Dear students, to factorize this, at first we need to multiply this. Otherwise we can take common anything. As we can take common anything from this given polynomial or from the expression, so we have to multiply this. If we multiply this, here we will get 2 terms, here we will get 2 terms, here we will get 2 terms. So total 6 terms we will get, and here is a term 3xyz, but there will be 7 terms. Dear students, if we take common from 2 terms, then we need 8 terms or 10 terms, even number of terms. If we take common from each 3 terms, then we need the number of term multiples of 3. It means 3 terms or 6 terms or 9 terms, but here is 7 terms. So it's not possible to take common if we multiply here, but this term remains same. We will get total 7 terms, as we will get total 7 terms. So we can write this as 3 terms, x plus y plus z, x plus y plus z, and x plus y plus xyz plus xyz plus xyz. So at first we have to multiply. In the first term, if we multiply, we will get x y square plus z square x plus y z square plus x square y plus z x square plus y square z plus x y z plus x y z plus x y z. So we can express 3xyz as sum of 3xyz. So we can write here now total number of terms we can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, total 9 terms. So we have to take common from each 3 terms. To take the common, we have to apply some technique, we have to arrange some terms so that after taking common, the factor remains same. The factor remains same in each case. So we have to select 3 terms. How can we select? At first, suppose we want to consider x square y, then x y square, and then x y z. If we take these 3 in this way, x square y plus x y square plus x y z. If we take x y common from these 3 terms, in the first term x will remain, in the second term y will remain, and in the third term z will remain. So these 3 terms, if we take common, we will get x plus y plus z. Now rest 3 terms we can select to get the same x plus y plus z after taking common. So what can we select here? We can select here z x square plus x y z plus z square x. Where is z square x? Here. So we can select this term and this term. Now 3 terms left. From this 3 term we can take zx as common, x will remain here. If we take zx common, y will remain here. If we take zx common, z will remain here. So next 3 terms remaining here, yz square, then y square z, then xyz. So at first take xyz, so that after taking yz we can get x, then after taking yz we can get y from z square, y square z plus y square z. Then the next term, last term, yz square, we can write here yz square. So I have arranged using technique. Now I can take common from first 3. If we take xy as common, x plus y plus z will remain, plus take zx as common, zx as common, x plus y plus z, plus take yz as common, yz is common, you will get here x plus y plus z. So now if you observe here, x plus y plus z, x plus y plus z, x plus y plus z. So we can take x plus y plus z as common. If we take this as common, we will get here xy plus zx plus yz. So we can arrange this as this is the form of cyclic expression. So we can write x plus y plus z, that is equal to xy plus yz plus zx. Okay, dear students, so factorization is done. I have obtained 2 factors factorizing this expression. So this is done. This is the answer. Okay, dear students, I hope you have understood how to factorize this expression. Okay, dear students, so keep practicing at home, abide by your parents, stay home, stay safe. See you again. Till then, assalamu alaikum.